we are given a vector, vector v, in component form. Its components are negative 2, comma 3. And for this vector, we want to sketch each scalar multiple below. And so we have a list of 5 different scalar multiples of this vector v. We have 3 times vector v, negative 1/2 times vector v, 0 times vector v, negative 1 times vector v, or just negative vector v, and then negative 2 times vector v. All right, and so let's work on each of these one at a time. But let's start with the first vector here of 3 times vector v. Now remember, when you multiply a scalar, such as 3, by a vector, what you do to find the resulting vector is multiply that scalar by each of the components of that vector. So for this first scalar multiple, our vector will be 3 times this x component of negative 2. So we have 3 times negative 2. And then for the y component, we'll have 3 times the y component of vector v, which is also 3. So we have 3 times 3. And 3 times negative 2 is negative 6. And 3 times 3 is 9. So this vector will become negative 6, comma 9. And so I'll write that in here. Okay, so now we can sketch this vector. This scalar multiple of vector v is the position vector of the point negative 6, comma 9. So if we go to our graph here, negative 6 in the x direction takes us to here, and then positive 9 in the y direction takes us here. So if I plot that point, that is going to be the terminal point of our vector. So I'll start at the origin and end at that point, and then draw an arrow to represent the direction of that vector. And so that is vector 3 times vector v. Okay, now let's work on our second vector, or our second scalar multiple of vector v. This time we have negative 1/2 times vector v. So what we want to do is multiply negative 1/2 by each of these components for vector v. So if we do that, we'll have that this is equal to negative 1/2 times negative 2, and then negative 1/2 times positive 3. All right, now if we simplify, negative 1/2 times negative 2, that's just going to be positive 1, right? The negatives will cancel out, and 1/2 times 2 is just 1. So this first component just becomes 1. And then the second component, we have negative 1/2 times 3. That's just going to become negative 3/2. So we'll have negative 3/2. All right, so now, if we want to sketch this scalar multiple on our graph, we first need to locate the point 1, comma, negative 3/2. Now, negative 3/2 is going to be the same as negative 1.5. 3 divided by 2 is 1.5. You can check that in a calculator if you like. And so if we go to our graph, we'll move 1 in the positive x direction, and then negative 1.5 in the y direction. So this is 1, and then 1/2 takes us to right here. So this point right here is the terminal point of this scalar multiple. And so if we actually sketch the vector, we will start at the origin, which is the initial point, and then we connect to our terminal point, and then draw the arrow to represent the direction of that vector. Okay, and so that is negative 1/2 times vector v. Now let's move on to our next vector, or our next scalar multiple. This time we have 0 times vector v, and if we multiply 0 by both of the components of vector v, both of the components are just going to become 0, right? 0 times negative 2 is 0, and 0 times 3 is also 0. So this vector just becomes 0, 0, which is also known as the 0 vector, and the 0 vector is just a point at the origin. And so sketching this scalar multiple is going to be pretty easy. We just have to draw a point at the origin. And so I'll do that right there, okay? And if you want, you could label that. I'm just going to write the 0 vector right there, okay? Now let's move on to the next scalar multiple, which is the negative version of vector v, or negative 1 times vector v. And so if we multiply negative 1 by each of the components of vector v, these components are just going to be negated, or we're going to have the opposite of those components. So negative 2 will become positive 2, and positive 3 will become negative 3. So negative vector v is equal to 2, comma, negative 3, the negative versions of the original components. So if we want to sketch this vector, we first need to find the point 2, comma, negative 3. So if we go to our graph here, positive 2 in the x direction takes us here, and then negative 3 in the y direction takes us here. So I'll draw that point right there, and then our vector is going to start at the origin and end at that point, and it will look like this. That will be the vector negative vector v. Okay, Now we have one more vector to work with here, and that is negative 2 times vector v. This is our last scalar multiple of our vector v. And to sketch this one, we first want to multiply negative 2 by each of the components. So that will look like this. We will have negative 2 times negative 2, and then negative 2 times 3, right? We multiply negative 2 by each of those components. Now, if we simplify, negative 2 times negative 2 will be positive 4, and negative 2 times positive 3 will be negative 6. So we'll have positive 4 here, and then negative 6 here. So we'll write positive 4, negative 6. And now to sketch this vector, we need to find a point for negative 6. So if we go to our graph here, 4 in the positive x direction will take us to 1, 2, 3, 4 right here. And then negative 6 in the y direction is 1, 2, 3, 4, 5, 6 right here. So I'll plot that point, and then to sketch our vector, we want to start at the origin and connect to that terminal point, and then draw the direction of that vector. All right, and so that is the vector negative 2 times vector v. Okay, and so now we have sketched all of these scalar multiples of vector v, and if you want, you could go ahead and also sketch vector v to compare these scalar multiples to that original vector, and I'll do that real quick. Vector v is the position vector of negative 2, 3. So negative 2, 3 takes us negative 2 in the x direction, and then positive 3 in the y direction, so this point right here. And so the vector would start at the origin, connect to that point, and it would be directed in that direction. And so that is vector v, and you can see that all of these different vectors, all of these scalar multiples of vector v, are parallel to that original vector, vector v. The only difference is the length of those vectors or the direction of those vectors. When we multiplied by a negative scalar, the direction of the vectors was reversed from the original.